Yeah, they're totally creepy. So today we are going to introduce something completely new. Okay, you guys, for once, have actually never seen this before. Okay, usually everything that we've been covering has been just an extension from Algebra 1, but today we are going to do something completely new. Okay, so we are going to simplify square roots of negative numbers. Simplify square roots of negative numbers. So, for example, number 1. If I asked you to tell me what is the square root of negative 4? Anyone? What's the square root of negative 4? What multiplied by itself gives you negative 4? No. Can you square a positive 2 and get a negative 4? No, you can't square a negative 2 and get a negative 4 either. So it used to be that was undefined. Okay? Now, unfortunately, I'm going to give you a new definition. Okay? This is not going to work anymore. The new definition that you need to know, is that the square root of negative 1 is equal to I. Okay? And I put the little tail on there so it looks more like an I, not like a 1. Okay, so the square root of negative 1 is equal to I. You also need to know that I squared is equal to negative 1. Okay, this is going to be the basics for the rest of basically up until winter break. Okay, this is the key thing that you have to memorize, that the square root of negative 1 is equal to I, and that I squared equals negative 1. Super, super, super important, right? These are something called imaginary numbers. Now, you will never see an imaginary number because it is obviously imaginary, okay? It's more of a theoretical thing, and my understanding, and I obviously am not an engineer, but my understanding is that they use this a lot in engineering, okay, when they're trying to construct, like, bridges or roads to figure out, like, the theoretical, like, threshold for weight. Okay, I really don't understand how they come into play, but I know that it's used a lot in engineering. So I know you guys like to ask me, when am I ever going to use this? Say for this one, for sure, it has something to do with engineering. Although I'm not an engineer, so I can't tell you what. So for this one, negative 4, okay, the new way we would do this is you would figure out that negative 4, that would break down to be negative 1 times 2 times 2. Would you all agree that negative 4 is equal to negative 1 times 2 times 2? Does that make sense? Okay. Immediately, you know that once you have a pair, it gets to come out from underneath the radical. Also, now you know that anytime you have a negative, just one of them, if you have a negative, it comes out of the radical to be an I. So the actual answer here, when I ask you to simplify, from now on, your answer is 2I, right? Anytime you have a negative number, you get to do these problems now. So this is one of those kind of good news, bad news things. It was kind of nice that you didn't know this for some people, because then you got to skip a lot of problems. Now you actually have, you know, a wider capability of math that you can do, but you actually have to do more problems now, right? So something like the next one, for number 2, I'd like you to simplify root negative 5. Simplify the square root of negative 5. So here, can you take out any pairs? No. So the 5 stays underneath. However, this negative does move outside and it becomes an I. So this would become I root 5. Okay? Please try to not confuse it for thinking that it automatically makes a pair, okay? You always just take out the I first and then anything else that can come out as well. So this one, square root of negative 5, is just simplified as I root 5, and they are attached to each other by plus or minus. You do not have to put any, or excuse me, by multiplication. You do not have to put any plus or minuses in between them because they are attached by multiplication. Try another one for number 3. Again, just simplify root negative 36. Square root of negative 36. For this one, first thing you do whenever you see radicals that have a negative out in there, first thing you do is take out the I. Then you try to take out any pairs. So here, this is going to be, you definitely are taking on an I. And what's the square root of 36? 6. We want to write this with the number in front. Okay, so you would write this as 6I, not I6. Otherwise, it just looks funny. It's kind of like, instead of saying like 2x, we never say x2. Okay, so you always put the number in front, then attach to the I. Question. Elijah, you good? Okay, so 6I. Try another one for number 4. And this isn't really something that I would say is very, like, difficult. It's just getting used to it and the thought process of I's. We'll see. It gets, a little bit more difficult, but nothing huge. We're just introducing I's today. So I'd like you to simplify 6 root negative 12. 6 root negative 12. So here, you know that you have a 6 on the outside. It is attached by multiplication. What are you going to be able to take out from underneath this radical? For sure, you can take out an I. I is always the first thing you should take out. Then, what does 12 break down to? 2 and 6. You can break it down however you'd like. You're going to end up with 2 times 2 times 3. Okay? At the end, whenever you break it down, you should get 2 times 2 times 3. So you should be able to take out a 2. So here we're really going to be multiplying a 6 times an I times a 2. Left behind will be the 3. So when you simplify completely, 6 times I times 2 gives you 12I root 3 for an answer. 12I root 3 is the answer that I'm looking for. Now I'm going to give you guys a rule here. Okay? There is a rule in math that says the square root of A multiplied by the square root of B is equal to the square root of A times B, but only if both of them to start with, so only if A and B are greater than or equal to 0. So what this is basically saying is you can combine things, okay? You can write things underneath the same radical, but only if both of the things underneath were positive to begin with. Okay, greater than or equal to 0 means positive, essentially. So I'm going to show you there is a difference. There's a really big difference, actually, between number 5 and number 6. And I'm going to write them both down. And I want you guys to tell me if you can, figure out the difference. Okay? Root negative 6 multiplied by another root negative 6. That problem versus root negative 6 times negative 6, all underneath the same radical. I want you to tell me, because this is either a quiz question or almost an exact test question, if I remember correctly. Will these give you the same answer? No. Okay? You cannot multiply things together until they're both positive underneath the radical. So here, before you can do any combining underneath the radical, you first have to take out an I. This becomes I root 6 times I root 6. Then you can actually multiply them together. What's I times I? I squared. Okay, we're not adding them, but we're multiplying them. So I squared times, you get a whole 6. What did we say I squared was? Negative 1. So I squared becomes negative 1. Negative 1 times 6. The answer here is negative 6. That is completely different than if they both are underneath the radical to begin with. Okay? Underneath the radical to begin with, you can actually multiply these together. The negatives cancel each other out here. This becomes the square root of 36, and the square root of 36 is positive 6. Okay, the reason that you only put the positive is your initial problem came with the radical. So remember yesterday we talked about if you introduce the radical, if you put in the plus or the radical in the equation, you have to put plus or minus. This one, your problem came with it, so you do not put plus or minus in your answer. Yes?
You said that I is negative 1, right?
No, square root of I. Excuse me, square root of negative 1 is equal to I. I squared equals negative 1. got the distinction? You had them a little bit backwards. Okay, so make sure that you kind of understand the difference between these two, because there's a pretty big difference. Okay, next one, for number 7, we are going to do 10 today, but they're all pretty quick. Okay, number 7, again, I'd like you to simplify. Quantity 5i squared. So 5i in parentheses, quantity squared. So the whole thing in parentheses squared. Here, would you say this is a binomial or a monomial? Is this a monomial? Is this one term or is it 2 terms in there? Just one. Okay? Things that are attached by multiplication are all one term. This is a monomial, so that means that you can just distribute this exponent. Okay? If you distribute the exponent, what's 5 squared? 25. And I to the second power is I squared. Then yes, I squared becomes a -1. So it's technically multiplying by -1. I'm just going to write it as a negative in front. So your actual answer here is -25. Okay, let's combine some stuff that we did yesterday with what we're doing today. How about 3 over root -7? 3 divided by root -7. Now, there's 2 problems here. Number 1, for answers, in math, there can be no roots in denominator, and you can't have any i's in a denominator for an answer. Okay, so here we actually have kind of 2 problems. If you simplified this would be 3 over, take out the negative as an I root 7. So here, this is a problem. Number 1, you can't have an I in the denominator. Number 2, you can't have a radical in the denominator. All you have to do to get rid of these is rationalize the denominator, just like what we did yesterday. Okay, to rationalize the denominator, you multiply exactly by itself. So we're going to multiply by an I and a root 7 in both the numerator and the denominator. Multiply both the top and the bottom by I root 7. In the top, you multiply across, so we get 3i root 7. In the bottom, I times I becomes what? I squared. Root 7 times root 7 becomes 7. I'm going to always write this with the coefficient or the number in front. Then we can simplify. Okay, what does I squared become?
What's the note say?
No radicals in the denominator and no i's in the denominator. I'm sorry, I squared becomes a negative. You can write that negative in the top or on the bottom or on the side. Okay, usually we write it with the top. Okay, so this simplifies completely, so we become -3i root 7 over 7. Can I reduce the root 7 and the whole 7? No. Okay, that's your actual answer. You cannot reduce a radical, or what's underneath the radical, with a whole number. Now, if you had 2 whole numbers out front that could reduce, you should. But this one is completely done. Anyone have questions so far? Okay, 2 more for you. For number 9, I would like you to simplify 4 over I. 4 over I. Simplify. Obvious problem here is that there's an I in the denominator. To eliminate the I in the denominator, we rationalize it. And to rationalize it, you just multiply it away. So we're going to multiply by I over I. If you multiply across the top, 4 times I is just 4i. In the denominator, I times I is I squared. Now, do not reduce these. Okay? If you reduce these, you're going to get right back to where you started. That's not what we want. So don't do that. Okay? I squared actually becomes what? -1. So 4i over -1. That doesn't really make any sense. So the actual correct way to write this is to move the negative up to the top, and this is equal to -4i. That's the answer that we're looking for. So they're all kind of pretty simple, basic steps, but you're just combining them all from what we did yesterday with rationalizing denominators and what we're doing today with introducing imaginary numbers. And then the last thing we're going to do is I'd like you to simplify 2 root negative 7 plus 3 root negative 7. 2 root negative 7 plus 3 root negative 7. Two root negative 7 plus 3 root negative 7. For this one, before you add anything together, you do want to get rid of those get rid of the i's. So here, this becomes what? 2 root negative 7. How would you rewrite that with i's? 2i root 7, right? So these negatives come out to become i's. So 2i root 7 plus 3i root 7. Do you think these are like terms? Yes. Okay, the like term part about this is the I root 7. So really all you're doing is adding together the 2 and the 3. So if you add 2 and 3 together, you should get 5i root 7 for an answer. That's the answer that we're looking for. Okay. You also need to know, and we're going to go more into this tomorrow, but just know that I by itself, anything with just an I attached is an imaginary number. Okay, just an I by itself is an imaginary number. If you have something which is an all reals, okay, so something that's reals and an I together, that is something called a complex number. And we will go more into that in the next couple of days. So I's by themselves are considered imaginary numbers. Real numbers, when they're combined with I's, are called complex numbers. Okay, so reals and I together are called complex numbers. Homework is up on the board. All you guys are doing is just the worksheet. Okay, so you're going to do the worksheet number 2. I do have packets for you, so don't let you leave without me getting those. Okay, and you're doing just the odds. So worksheet number 2, numbers 1 through 30 odd. And I will give those to you. Now, anyone else have questions?